and I'm happy now to transition to our keynote speaker, Christophe Hartmann. Christophe, please welcome Christophe on stage. Christophe has a strong academic background. He started his career as an assistant professor before joining Nestlé in 2006, where he had different positions, and now he's leading the academic alliance of Nestlé on a global scale. Christophe?
So, thank you. Good afternoon. It's for me a great honor and a big pleasure, obviously, to be here and to present you a little bit of how we leverage, actually, academia, the bright minds we have in academia. So I'll talk about how making public-private partnerships work. But before I do that, I would like to give a little bit of a background introduction on what problems we face in the food and nutrition world. This is an artist's interpretation of the food system, so it's actually the combination of all human activities that are dedicated to supply food to 8 billion people every day at least 3 times. And it illustrates the flow of biomass, of water, of energy, of information, and of course also of money. Yeah? And you see that there's a central axis, which actually is the axis from agriculture, primary production, to right away on the right-hand side, consumers who consume the food. But then you see also a lot of other tensions there in this picture building up: regulatory, climate, waste streams, and so on. This system that serves us every day individually is currently under very strong stress. It is influenced by many global challenges that we all know. It is also contributing to making actually these global challenges even bigger. First one is population growth and urbanization. More people on Earth and more people living in cities require more food and even more packaged food. Secondly, climate change. Climate change puts at risk primary production very much. At the same time, agriculture strengthens and accelerates climate change. So it's actually a contained loop, right? Then we have economic crisis, conflicts disrupting supply chains, which are global today, and which put at risk people in some areas in the world on their daily requirements on food intake. So the question is now, how can industry, as I'm from industry, how can industry help stabilize this food system? Yeah? There are actually 3, probably more things to do, but at least 3 big topics. It's first, use water, energy, and the biomass that ultimately we eat more efficiently. Reduce emissions, so greenhouse gas emissions, of course, but also any kind of waste. Yeah? And finally, also design better products so that people get better nutrients and that these products also are, let's say, more sustainable for the entire planet. So that's at stake. Now we, as industry partners, we are, this was too fast, sorry for that. In this food system, you barely find us there because it's so big. Yeah? But the food industry is a little bit lower left from the consumer side. So it's just one player in this big world. So how can we provide an efficient stabilization mechanism to this system which is running out of balance? Well, one way to do is of course to team up, and we do team up a lot with other corporate partners. We work with suppliers, we work with customers, and we try to reduce waste, reduce inefficiencies in this food chain. Yeah? But of course, we also team up with academia. Yeah? And this brings me to this slide. So you see here, these are 2 worlds meeting. There is the industry world, which is, I would say, driven by a culture that is more guarded, cautious about releasing information, cautious about disclosing new discoveries, new solutions, and because of the need to monetize these inventions. On the other side, we have academia, universities. By default, their mission is to deploy, to disseminate new discoveries, new knowledge to young people, but also to the world, to enable other users to make applications out of it. Yeah? So how can you bring them together? Well, there are actually a lot of opportunities, as you see. Yeah? First, industry has an interest, of course, to tap into the great brains of university researchers. We strengthen through that our R&D capabilities. We can, through that, increase a competitive advantage because we do discoveries and inventions and translations of those faster. And of course, we get also access to talent. That doesn't mean that industry will actually recruit each and every talent which is on the market. But no, we think now in ecosystems, yeah, that you have a collaboration ecosystem, and in this collaboration ecosystem, in universities, in other suppliers, in other corporate partners, you have talents everywhere, and together we work sometimes, most of the time I would say even, towards global challenges, overcoming global challenges. Yeah? So on the benefit side, on the right-hand side, you see actually, a faster pathway from scientific discovery done in an academic environment into something which can then translate into solution for end users, people like you and me. Yeah? We see the development of collaboration and talent ecosystems. We see also opportunities to actually get access to equipment, facilities, which are of mutual interest for both parties. So we have university staff coming to our development centers, and we have industry staff going into university labs using facilities there. And that's just of mutual benefit. And the last point I would mention as a benefit, but this is more on the industry side, it's extremely important for us, Nestlé, in that sense, is also to gain, maintain, and strengthen scientific credibility. Yeah? Because you can imagine that, we as a company, we are very often in contact with, for example, regulatory authorities, with technical bodies of governance, and we need to show that our results are scientifically sound and argumentation is scientifically robust. Yeah? And hence, we can only do this through training ourselves as being good scientists, and how doing this better than through collaboration with academic scientists. Yeah? Good. So this is our Academic Alliances program. Currently, as of today, we have 128 active university collaborations around the world with 80 universities. About 10 of those universities, we call them strategic partners. Why are they strategic? Because our engagement with them actually stretches over several levels of interaction. And you see them shown on the pyramid on the right-hand side. You see sometimes our engagement is just we brief a group of students that needs to do a practical project in a course of a professor. We sponsor a conference. We speak at a conference. Sometimes we teach in curricula at certain universities. But then also we do research collaboration. This is the core of our academic engagement program. So we do research collaboration sometimes in consortia with more than one university and with more than one industry partner in the same program, but sometimes only bilaterally, because we want really to have a very fast pace and we want to secure also IP, whether it belongs to the university or to Nestlé, that doesn't matter. And then if we climb further up in the engagement, we also consider faculty affiliations. So Nestlé staff being member of a faculty. But then ultimately also on a strategic level, we cultivate the good habit of having top-to-top meetings. This means basically the university leadership, university president and his team or her team meet with Nestlé senior managers, CEO, CTO, and direct reports, for example, to align on longer-term strategies. And that helps, first of all, acknowledge the good work which is done in all those collaborations that we have, and on the other hand, to give a long-term vision and a long-term direction to such a public-private partnership program. I give you now a few examples. So with EPFL, we work in 3 major areas. One is life sciences. It's about nutrition, cellular nutrition, systems biology. I will not go there today in examples. The second area is material science, and here mostly dedicated to finding new solutions for food packaging. Yeah? And then the third area is the digitalization area, digital intelligent systems and robotics. Yeah? So here you see 3 examples. I will not go through all the details, but one on the right-hand side, I would like to start on the right-hand side with Tiffany Abitbol. Yeah? So we work with her on new packaging materials that are essentially new versions of high barrier paper, high barrier cellulose-based materials that are going to replace some of the single-use fossil-based plastics. Yeah? And that's a very difficult task because fossil plastics or plastics, polymeric plastic is typically very, very suitable for packaging, and paper is only suitable limited. So we need to do some engineering work to upgrade paper towards something which is tighter against oxygen, against water, and against also light, for example. Yeah? Then in the center part, we work now on polymers. Yeah? We work especially on recyclable polymers and on biodegradable polymers. Those polymers today are not fit for purpose in food packaging. They are not resistant against mechanical stress or thermal stress. So we need to do something with it to make it strong enough and fit for purpose in these applications. Yeah? And then on the left-hand side is a fantastic project we did with Francesco Stellacci. It was completely, coming from a different angle. During the COVID pandemics, we were thinking about, okay, how can we make our Nespresso machine safe against contamination, by using the touch screen, contamination with the coronavirus. Yeah? So we invented here actually a surface coating which is bactericide and also active against viruses, including the SARS-CoV-19. Yeah? So it works very well. And now we are in discussions how to use this on a large scale, even beyond the food and beverage area. So we see here applications broader than just packaging on espresso machines. We see hospitals, we see office furniture, and so on and so forth. So still under discussion and for further considerations on deployment. Then intelligent systems, digitalization, robotics. This is still an area in the food world where we have to find our way, because at the end, food is very material. Food is not data. Yeah? Data is food for thought, but food you still need to ingest and digest, and it needs to give you energy. So we have here taken 2 examples. I start with the left first. This is related to our systems technology, so Nespresso machines. There today we design actually our electronic components with hardware and software integrated systems, which makes actually the use of the technology that we have in the Nespresso machine usable for different platforms, makes it much more efficient, and we can actually do a kind of fleet maintenance service on all our Nespresso machines worldwide, yeah, from a distance. And secondly, we developed here with David Atienza also a capsule recognition system, so that the machine recognizes which kind of beverages you want to extract, and it will adapt the extraction parameters. Even one step towards personalization, because you can also define your own preferences of such a beverage on your own in a future version. And then on the right-hand side, this takes me again back to the global challenges. Now in the food industry, we have really enlarged the spectrum of the agricultural materials that we use to ensure supply on the longer term, and also to help people shift towards healthier diets. Yeah? And now, if you replace one ingredient in a food formulation, in an industrial food formulation, by another ingredient, which is maybe better for the health or better for the planet, yeah, you encounter surprises once it goes into the industrial operation processes. Yeah? So we do here a lot of work on reformulation of our recipes or inventing new recipes. Yeah? And this is done typically in a lab, in a bench scale operation, and it is done by a human product developer, very often in a very iterative and repetitive way. So we said, maybe we can use here also, self-learning systems, intelligent systems, in combination with robots. Yeah? And this is what we currently do, explore, pretty successfully, I would say. First results are very promising with Josie Hughes. So there we develop currently products driven through an algorithm and a robot, and we are looking forward to see, the first ever food product formulated by an intelligent robot. more to come. Yeah, I would like to conclude my talk with the Nestlé EPFL collaboration by numbers. These are numbers over the last 5 years, so to say. We have, you see, I will not go through them all one by one because would be too comprehensive, but you see there is a very strong intensity and bandwidth of research, and it goes indeed from research collaboration to teaching, to endowed chairs, endowed professorships, to postdoc programs, to PhD programs. And we are proud of that because EPFL is probably one of, I would say almost surely, one of the most integrated academic partners that we have. So it means basically with EPFL and only a few other universities in the world, we play on all the chords of what makes up an academic partnership with industry. Thank you very much for your attention.
Thank you very much, Christophe. Thank you very much for your presentation, giving insight about what Nestlé is doing, how you collaborate with academia, and also sharing the different research projects you are doing with us.